Well, now we're going to take a look at these inequalities, but we're going to change it up a little bit, throw an and or an or in there, put a couple of these graphs together in that were individual in the last section. Will go together in this section. So I again do not want you to write these in the space that's provided. I would rather you find some other place to write them, put them on a separate sheet of paper. And so now what ends up happening here is that if I put a shade on this, I've got two separate problems here. The first one is this: negative 2x greater than negative 8. Well, I divide by negative 2, and I get x on this left side. Negative 8 divided by negative 2 is 4. But it doesn't matter if I get an answer that's positive. The fact is that I divided by a negative 2. So when you divide by a negative number, that inequality has to switch. So I have x is less than 4. Okay, so there's the first one. The second one, way over here. I've got an and in between, so I'm going to put an and here. And then I'm going to divide and solve this one. So I get divide by negative 3. I get x. Inequality has to switch. 6 divided by negative 3 is negative 2. So when I get rid of this, this is my answer in terms of my inequalities. It's just two separate problems. Okay? But look what happens when I put those two separate problems on a graph. I've got a 4. I've got a negative 2. And in these problems, you can go and you can put a number that's bigger than 4, a number that's in between these. Well, between negative 2 and 4, I know that's not to scale, but between negative 2 and 4 is a 0, and less than negative 2 is a negative 3. Okay? And so I have all these different places. But these are the two that need circles on them. The 4 is less than, so I have an open circle there. The negative 2 is greater than, so I have an open circle there. Okay, so both have open circles. Now I want the numbers that are less than 4. Well, when I fill in the numbers that are less than 4, it goes this way. And then I want the numbers that are bigger than negative 2, so that goes this way. Okay, well, look at what happens if I were to draw those two lines in above here. Those are the numbers that are less than 4. These are the numbers that are bigger than negative 2. And so there's an overlapping place in there. That overlapping place is the place that actually answers this problem. Because I want a number that is less than 4 and it's bigger than negative 2. If I were to take, let's say, even this number 5, okay, that number 5 is bigger than negative 2. There's no doubt about that. But that number 5 is not less than 4. It has to be less than 4 and bigger than negative 2. Okay, it has to satisfy both of those things. And so the only numbers that satisfy both of those things are the numbers that are in between here that are now double shaded, one in red and one in black. Okay, those are the numbers that are less than 4 and bigger than negative 2. Okay, so that's an important idea for us. It doesn't change the fact that there's an infinite number of answers. There's still an infinite number. You can give me any number that's bigger than negative 2 and less than 4, and I can give you another one. And then you can give me another one, and I can give you another. And there's an infinite number still in between there, which is why we do all the shading. So let's take a look at this one. Let's put that shade back on here. The left-hand side one is a nice friendly equation. I'm going to add 3 to both sides. Maybe. I'm frozen. Whew, I think I fixed it. Plus 3, add 3 to both sides. So I get 2x on this side. Greater than 1 plus 3 is 4. I'm dividing by a 2, and x is greater than 2. I don't need to do anything with the inequality to switch it, because I divided everything by positives. Whoa, got a nice little line here. I've got and down here. Let's get rid of this extra line that came about. This nice friendly equation, add 1 to both sides. 3x less than 3, divide by 3, and I end up with x is less than 1. Okay, so I get rid of this, and I end up with x is greater than 2, and x is less than 1. So when I graph it, I've got the number 1 and the number 2, number that's bigger than that, a number that's in between them. 1.5 is in between 1 and 2, and a number that's less than 1. That's a 0. The 1 and the 2 are the numbers that are going to have circles at them. Okay, so I've got x is greater than 2, that's an open circle. X is less than 1, that's an open circle. I want all the numbers that are bigger than 2 and less than 1. Okay, so that looks like this. Numbers that are bigger than 2 go this way. And the numbers that are less than 1 go this way. Okay, the word "and" in between says, well, I need all the numbers that are bigger than 2. So if you give me a big number that's bigger than 2, let's say 3, because it's the one that's on our graph here. So if I take this number 3, that number is definitely, no doubt about it, bigger than 2. Okay. However, with the word "and" in between, it also has to be less than 1. Is 3 less than 1? I hope you said no, because 3 is definitely not less than 1. So it's bigger than 2, but it's not less than 1. And so this answer to this problem actually is no solution. There are no numbers that will go into the first equation and into the second equation to make the answer correct. And our graph shows that. There is no overlap. There's nothing that works for the first one and for the second one. Okay, so be careful about that when you look at those problems. Number 64 here, this is just a different version of an AND problem. So there's two ways that you can do these types of AND problems here. Okay, and so I have, we'll do this one by separating this into two different problems. Okay, and the first one, let's throw our shade on here. The first one here is a nice friendly equation. Subtract 4 from both sides. I get -9 less than 3x. Divide by 3. I divided by a positive, so even though I ended up with a negative number here, I still have a positive. The majority of us like when that x is on the left-hand side. It's the inequality opens to that x and gives me -3. So I end up with x is greater than -3 for that one. Then I go to the second one here. The second one, this is an AND problem. The second one, I'm still going to subtract 4 because that's my next step, or my first step in this. So I get 3x less than 16 minus 4 is 12. Divide by 3, and I get x is less than 4. So I've got one in red and one in blue here. So let's draw the line. I've got a -3. A number that's less than that is -4. I've got 4. A number in between that is 0. And a number bigger than 4 is 5. The -3 and the 4 are going to have the circles. X is greater than -3. That's an open circle. And x is less than 4. That's an open circle as well. Take a look at what these say. X is less than 4. That's all the numbers that go this way. X is greater than -3. That's all the numbers that go this way. I have an overlap. That overlap is going to be my answer. So my overlap is here. I want all the numbers that are bigger than -3 and less than 4. And that's all the numbers in between there. So then, well, when we look at the back of this page, we have that same situation, but this is just another way that we could solve it. It's still an AND problem, so I still have an AND problem at the end. But if you noticed on the last one, I did the same first step. So I can do that first step to begin with to all 3 different places instead of just 2 of them. So -6 minus 14 is -20. The 5x is still in between. This 14 went away, and 24 minus 14 is 10. Well, again, if you notice the same step that happened on the last problem, I'm going to divide by 5. So -20 divided by 5 is -4. These cancel, and then I get just x, and 10 divided by 5 is 2. Okay, so now when I look at this is a little bit better situation for me in terms of graphing, because I can again keep plug all these things in here. I've got a 0 in between here. I've got closed circles because they're equal to, but the circles are going to go at -4 and 2. Those are my answers. So I get 2 closed circles, one at -4 and one at 2. Now this says that all the numbers that I want are between -4 and 2. Well, that makes sense on the graph. I just want to graph that, all the numbers that are between -4 and 2. But if you look at this in terms of two different things, I've got x is bigger than or equal to -4. So I want the numbers that are bigger than -4, which go this way. And then if I look at this this way, x is less than or equal to 2. I'm looking for the numbers that are less than or equal to 2. I end up with an overlap that fills in between. Those are the numbers that are between -4 and 2. So there's a logical reasoning that goes into if I wanted to solve the problem this way. The only other type of problem that we haven't looked at is an OR problem. Okay, and so I look at this problem, but I've got, again, the same situation where I've got two things here, two different problems. I solve this one by multiplying by the denominator first, so I multiply by 3 to make it go away. I get 2x greater than 12, divide by 2, and I get x is greater than 6. There's my first one. Here's my second one. It's got an OR in it. I'm going to divide by 2, and I get, that's the only step here, so -8 divided by 2 is -4. I divided by a positive, even though I ended up with a negative answer. I still divided by a positive, so there's nothing that has to happen as far as the inequality switching. I look at this in a graph. I've got the numbers at -4 and 6, a number bigger than that, a number in between those, and a number less than -4. I've got an open circle at 6 and an open circle at -4. I'm looking for the numbers that are bigger than 6. So the numbers that are bigger than 6 are numbers that go this way. I'm looking for the numbers that are less than -4. Those are the numbers that go that way. But this time there's an OR in between. So the last time that I had that situation, it was an AND problem. And we said that it was no solution because there are no numbers that were bigger than the larger one that are also smaller than the smaller one. Well, in this situation, if I say, let's take, again, the number 7 here, the number 7 is most definitely bigger than 6. Okay? And if I had an AND in between there, it is not less than -4. But I don't have an AND, I have an OR. Okay? If I went to McDonald's and I said, can I have a Big Mac or a small Coke, then I would either get a Big Mac or a small Coke. I wouldn't get both of them. Okay? So then in the situation where there's an OR, this type of a problem ends up being, it can be one or the other. Okay, it doesn't have to be both. And means it has to be both, so there has to be an overlap. Or means that it doesn't have to be both. There can be a separation between those, and it'll still be okay. And so this is the answer to this. Here's the graph. Just to be consistent with the other problems, we were shading the lines down here where the correct answer was. And so either you can have this upper part and this upper part, or you can have the two parts that are filled in on the graph. Either one of those are fine. It doesn't matter either way. You will get it correct, and we will know what you're talking about as long as you draw them in one or the other. When we look at this worksheet, we're going to be doing the even problems. Okay, so go through, do all the evens, and make sure you're asking questions as you're going along.